Hi, my name is Justin Calvalli with Engineering Pro Guides, and this is another video on the FE Mechanical Exam, Probability and Statistics, where there are 4 to 6 problems out of the total 110 problems on the exam. This is part 3C on probability distribution tables, and we're specifically covering the student or T distribution tables. The T distribution is used when there is a limited number of samples within a larger population. It is also used when the standard deviation of the population is not known. So the T distribution can be used to estimate the probability distribution of the population given the sample size and the degrees of freedom. So the term degrees of freedom, as we previously discussed, is the number of independent observations within the sample set, and is typically shown by the equation below, where degrees of freedom is equal to the number of samples minus 1. So in order to use the T distribution tables, you must first find T, and the equation for T is shown below, and it's also in your FE Reference Handbook. It is the sample mean minus the population mean divided by the sample standard deviation and then divided by the square root of the number of samples. So in this T distribution or T distribution tables, you are given a sample out of an overall larger population, and you typically have a guess or a hypothesis as to what the population mean is. And so you're going to use the sample mean from this total number of samples and number of samples and the sample standard deviation to test whether or not the population mean is reliable. So when you are doing a problem, you're going to have to use the T distribution tables. And the way that you use these tables is first you go to the appropriate row, which shows your degrees of freedom. And once you find your degrees of freedom, you are going to find the closest T value. So if you don't have the appropriate T value, then you can interpolate between the two nearest values. If the value is too small for the table, then this typically means that you have a population mean hypothesis that you should be confident in. If you have a t-value that is too high for this table, then the population mean is most likely not reliable. So the values are also for one side of the distribution curve. So you can also double the value to get both sides of the distribution curve, assuming you are dealing with the absolute value of t, and this value will be shown in the practice problem later in the series. And one important value that you need to know is the magic value, which is 5%. And typically, once you go past this value, you start to lose trust in the population mean. If it's on the left side, then the population mean is trustworthy. If you are looking at the absolute value, then you're going to be looking for the 2.5% because you have to include both sides. And so 2.5 plus 2.5 will be equal to 5%. Okay, that's all for this video. Please go on to the next part.